This video covers sampling distributions for the difference between means and how that affects probability problems. And so the parameter of interest in these problems is mu1 minus mu2, and we estimate this parameter using the point estimate x bar 1 minus x bar 2. Don't forget you always need to check your assumptions. In these problems you need to check that there are two independent simple random samples, and then you need to check the central limit theorem for each sample. If your population is normally distributed, the central limit theorem does not apply. However, if it tells you the population is heavily skewed, you need to check that the sample size is greater than or equal to 40. And if it does not specify the distribution, the sample size needs to be greater than or equal to 15. Once your assumptions are satisfied, you can then describe the distribution. We use the notation that the point estimate is distributed normally, and you can find your mean and your standard deviation on the formula sheet. Then this notation covers the center spread, shape, and unusual features, which fully describes the distribution. If we look at a quick example, of interest is to compare the mean delay times for all flights leaving Ronald Reagan Washington National Airport to the mean delay time for all flights leaving Dulles International Airport. Suppose the mean delay time for flights leaving DCA is 9 minutes with a standard deviation of 4. The mean delay time for IAD is 11 minutes with a standard deviation of 3. A simple random sample of 50 flights from DCA and an independent simple random sample of 40 flights from IAD are chosen. If appropriate, describe the sampling distribution of the difference between the sample means. In these problems, you first need to specify population 1 and population 2. I have chosen DCA as 1 and IAD as 2, and this will help me keep track of all of my variables for each population. So DCA has a mean of 9 minutes and a standard deviation of 4, and we collected a sample of size 50. And for IAD, it states that the mean delay time is 11 minutes with a standard deviation of 3, and we had a sample size of 40. Then I can go ahead and check my assumptions. We have two independent simple random samples, and the distribution of the populations is not specified, so 50 and 40 are both greater than 15, so this satisfies my assumptions. Then I can plug all of my values into the formulas, and then I can solve for my mean and standard deviation. So in this problem, our point estimate is distributed normally with a mean of -2 and a standard deviation of 0.738. Once you have a description of your distribution, you can then be asked to find the probability for a difference in the sample means. Suppose we want to find the probability that the difference in the sample means is negative. In these problems, you can just use the normalcdf function in the calculator. When you see the difference in the sample means, you need to use your mean and standard deviation from your sampling distribution. And if you need help finding probabilities, you can go back to our previous videos on normalcdf functions as well as finding probabilities for normal variables.